Okay, today we're going to start learning about triangles. So just as we've been talking about angles, triangles have specific things that let us figure out how many degrees are in each angle. So first thing we need to know is all angles in a triangle must add up to be exactly 180 degrees. And do you know why? We're going to go through a little bit of a proof here. So if we were to draw a straight line, get a line here. If we were to draw a straight line, it's parallel to the base of the triangle. Okay? And here, we can even continue our triangle out to make it easier to see. And it's like we took this triangle and we just flipped it upside down. So let's call this angle 1. Angle 2, and angle 3. Well, if you look right here, our pink angle is alternate interior with this angle. And if you see our green angle, it's alternate interior with this angle. Because we can treat this line right here as a transversal, and we can treat this line right here as a transversal. And then our blue angle stays the same. It's like our triangle just went from being up here to flipped over. So these three angles on a straight line are supplementary. And so now when we look at our relationships, we see that all three angles inside a triangle must equal 180 degrees. Now, to figure out the missing angle measure, all you do is add up the angles that you have and set them equal to 180. So right here we have 86 degrees plus 33 degrees plus x equals 180. Well, we know that 86 plus 33 is going to give us 119 degrees plus x equals 180. We solve this just like a one-step equation. We're going to subtract 119 from both sides. Subtract 119. Oops, put a 1 there. These cancel out, and we see x is equal to, what is that? 180 minus 119. 61 degrees. 61 degrees. Okay? And then you can plug it in for x. Check your work by adding all three numbers together. If they equal 180, you did it correctly. Now, is it possible to construct a triangle with the angle measures of 54, 23, and 103 degrees? All right, so add up all three of the angles, and it's just a yes or a no. 54 plus 23 plus 103 is equal to 180. So yes, it is possible to make a triangle with these three angles because they add up to 180 degrees. That's all you have to know with angles. If they add up to 180, it's a yes. If they don't, it's a no. And so how many different triangles could we make using the angle measurements above? We could make an infinite number. Infinite number. Meaning all triangles that we make with these angle measurements will be similar, so they're proportional to each other. The angles are the same, the sides are proportional, and this is what we call the triangle sum theorem. All angles inside a triangle must equal 180 degrees. So again, here to find the missing angle measure, all we do is add our three angles together. M plus 50 plus 79 plus 34. This is all in degrees. They have to equal 180 degrees. Now if we add up, combining our like terms, 50 plus 79 plus 34, we get M plus 163 degrees is equal to 180 degrees. Now again, we just subtract 163 from both sides. and we get that M is equal to 17 degrees. Now we're not finished though, because the question says find the missing angle measure. And all we did was find out what M is. To find the missing angle measure, we have to add M plus 50. And we know that M is 17 degrees, so that plus 50 is going to equal 67 degrees. And now if you add 34 plus 67 plus 79, you'll check and see that we have 180 degrees inside our triangle. Here again, we're going to find the measure of angle A. We have a few things to look at here. We don't have a number in this angle, but we have this little box which tells us that's 90 degrees. So again, we combine our like terms. We just set all this equal to 180. So 90 degrees plus x plus 2 plus x plus 5 has to equal 180 degrees. And we're trying to solve for angle A over here. So we're going to combine our like terms. 90 plus 2 plus 5 gives me 97. And x plus x will give me plus 2x equals 180 degrees. Again, this is a positive 97, so we're going to subtract 97 from both sides. And I'll come over here. We see that 180 minus 97 gives us 83. So we have 2x is equal to 83 degrees. Okay? Well, now we divide by 2 on both sides. So divide by 2, and we get x is equal to 83 divided by 2 is equal to 41 and 1/2, or 41 and 5/10. Now, to figure out angle A, we have to add this together to 5. So we have 41 and 5/10 plus 5, and that's going to give us a measure of 46 and 1/2, or 46 and 5/10 degrees. So now we're going back to our angle relationships. If angle A and B are complementary, and we know that B is 40 degrees, then what is angle A? Well, we know that our complementary angles equal 90 degrees. So all we have to do to figure out angle A here is subtract 40 from 90. So 90 minus angle B's 40 degrees equals 50 degrees. So angle A is 50 degrees. Now, our triangle inequality theorem. This tells us the sum of the lengths of any two sides of a triangle is greater than the length of the third. Meaning, take the two shortest sides and add them together. They have to be greater than the longest side to be able to make a triangle. So can you construct a triangle with sides measuring 5 inches, 8 inches, and 15 inches? Well, we just have to pick the two shortest sides, which are 5 and 8. 5 plus 8 is 13. 13 isn't greater than 15, so no, we can't create a triangle with these side lengths. Now, if we look at example 8, River constructs a triangle with one side of 5 centimeters long and another side of 8 centimeters long, which is not a possible length for the third side. Well, we know our two shortest sides have to add up to be greater than the longest side. So we know 5 plus 8 is 13, so it cannot be equal to 13. We cannot be equal to 13. That's not my highlighter. Because it doesn't say equal, it says greater than. So 10, 11, and 12 would work, 13 does not. So to find the range of possible measures, for the third side, subtract the 2. So 11 minus 7 gives us 4. Move that in there. And then add the 2. 7 plus 11 gives us 18. So we know that our range of sides can be anywhere between x has to be greater than 4 and less than 18. Now what's the range of possible measures for this triangle? Again, we subtract the two, so 15 minus 8 is 7, and 15 plus 8 is 23. So in our range of possible measures, the number has to be greater than 7, but less than 23. And that's it for triangles part 1. Now do the exercises given to you.